Hello there, this is Professor Eckhouse, and I'm going to talk about real numbers and algebraic expressions today. You might want to pause the video and read about what we're going to learn. It's always nice to know what you're going to learn before you learn it. Just so you know, this section right here, most of defining and using the properties is going to be done from the textbook. I'm trying to keep the videos a little bit shorter, so there are some things that you're going to be looking in the book or looking at the videos that are in the problems for. All right, so first we want to classify real numbers before we get started with the rest of this. So there are natural numbers, whole numbers, and integers. And I'd like you to pause the video and write all of this down, and then I'm going to talk about it. All right, so hopefully you had a moment to write these down. Natural, whole, and integers belong to those sets. As you can see, the natural numbers are inside the whole numbers, which is inside the integers, which is inside the rational numbers, which means if something is a natural number, then it's also a whole number, also an integer, also a rational number. Okay, and these all belong to the set of real numbers. Okay, the other kind is imaginary, which we're not going to be talking about in here. Okay, so real numbers. All right, so what I do want to talk about, though, here is the rational numbers and the irrational numbers. So a rational number, the word ratio, hopefully makes you think of a fraction. So a rational number can be written as an, I'm going to make that smaller there for you. It can be written as a fraction, where m and n are integers, okay, which means they're whole numbers that can be positive or negative. So in decimal form, what do they look like? So they can either be a terminating decimal or they can be a repeating decimal. Terminating is like this one where it ends, right? 7/8. If you put 9/11 in your calculator, 9 divided by 11, you get 0.818181 ... which means forever. And your calculator might actually round it for you, but you don't want to round it. It really means it goes on forever. And we write that as 0.81 with a line over it saying that the 81 is repeating. All right, an irrational number is something that cannot be written as m/n. Okay, so you can't do it. It doesn't work. There's no way to make it turn into a fraction. It will continue forever like without repeating like pi. Okay, so the big key thing here you need to know is that the square root of an integer that is not a perfect square is often irrational, and for the sake of this class, you can assume it is irrational. Okay, so we're talking about something like the square root of 3, or the square root of 5, or the square root of 6, and so on. Okay, so they're not perfect squares. We take the square root of it, it's probably going to be irrational. Okay, so the way to tell when you look at the decimal is it's either terminating or repeating, and it's rational. If it continues forever without repeating, like pi, then it is irrational. Or if it's a square root of not a perfect square, a number that's not a perfect square. All right, so let's move on and classify these. So take a look at this table right here and see if you can classify each of these by just putting a check mark in each box. You're going to see something like this in the homework. So just to make sure you're clear, n means natural, like counting numbers. W means whole. I means integer. Q means rational. Q prime means not rational or irrational. And R means real. So pause the video and try to fill this out. All right, hopefully you took a moment to pause the video and try this. So square root of 64 is just 8, right? It's a perfect square. So that's a natural number, that's a whole number, that's an integer, and it's also rational. So remember, if it is natural, then it is all these other things too, right? All of them. So if it's natural, it's also whole, it's also an integer, it's also a rational number. And that's where this Venn diagram is hopefully helps you a little bit. All right, so 5/7, if you put it in your calculator, you're going to get a number that, well, it doesn't really matter if you put it in, but it's a number that should repeat or terminate, but you don't need to put it in your calculator because it's already as a fraction. So it's two integers in fractional form, so we know it's rational. It is not an integer, it's not a whole number, and it's not natural because it's a fraction. All right, the next one, square root of 3. 3 is not a perfect square, so this is an irrational number. We forgot to talk about if these are real or not. Are these real? Well, everything that's rational or irrational is going to be real. So all of these are real. Is -9 real? Yes. Is the next one real? Yes. Is this one real? Yes. All the numbers you're going to see in this class are real. All right, so let's go back to -9. All right, -9 is not natural because it doesn't include the negatives, and it's not whole because those don't include the negatives, but it is an integer, which means it's also rational. All right, 5.232323 can also be written as 5.23 with a line, a bar over the 23. All right, so since it repeats, it's rational, but since it has decimals in it, it's not natural, whole, or an integer. All right, the next one, if you look at it, it's 2.515115111. There's nothing repeating about that, so that is irrational. If I put pi in here, what would you say to that? Well, that is also irrational, and of course it's real. All right, so let's move on. So there are some properties of real numbers that you need to know. See the online book for these. Take a moment to write them down. I'm going to make this a little smaller so you can see them all at once. This is in the book. There's a video at the end that has more details, and I'm just going to let you pause and write these down. Okay, so moving on, why is there no distributive property of multiplication? So it's blank right here. Why is there nothing there? Well, think about it this way. If you've got A times B times C, and you distribute it like you do with addition, which I see people do all the time once they learn these, and it is not correct because you would get AB times AC, which is A squared BC. Sorry, that's a terrible C. Let me fix that. Right? So that's not what we have at all. That's just A times B times C. So A times parenthesis B times C means we could also call that AB times C, right? Or we can call it BA times C. We can change the order according to these other rules up above, but we cannot distribute it. Okay, so the distributive property does not happen with multiplication. Okay, so this is incorrect. Put a big X in it if you wrote it in your notes. All right, so see the textbook for examples of using the various properties. So in order to look at just ways to use it, there's lots and lots of examples in the textbook. All right, so moving on, take a moment to put this in your notes, and then I'm going to talk about it. All right, so if you have any questions about any of these, please make note of it so you can ask me in class. But a couple of really important things here is that an algebraic expression does not have an equal sign. An equation is two expressions set equal to each other. Let me change the color of that so it matches what I did up above. Two expressions in yellow set equal to each other. Okay, make sure you understand the difference between a coefficient, a variable, and a constant. All right, so an expression, one more time, does not have an equal sign. An equation does. Okay, so can you solve an algebraic expression? No, you cannot. Right, so it's just an expression. If I said 2x minus 3, can you solve that? Absolutely not. There's no equal sign. There's nothing to solve. You can evaluate it. If I told you what x was, you could plug it in, but you can't solve it. All right, so what does an exponent represent? What does an exponent represent? So it represents, so 2 to the 4 means 2 times 2 times 2 times 2. Okay, so this means that an exponent represents repeated what? Multiplication. All right, so negative 3 squared means negative 3 times negative 3, which, by the way, equals what? 9. Negative times a negative is a positive. Negative 3 squared, I just wanted to point this out. I'm going to do a different color because this is different. The squared only applies to the 3. In this case, the squared applies to both because of the parentheses. In this case, it only applies to the 3. So now what do you think? This would be negative 3 times 3, which is negative 9. All right, so note the differences between those two. All right, 2/3 times 2/3 is what this means, which is basically 2 times 2 over 3 times 3, which is 4 over 9. In other words, 2 squared over 3 squared. right, this next one is xy times xy times xy, and according to the properties we just learned up above, we could take away the parentheses and just say x times x times x times y times y times y, which is x cubed y cubed. All right, so in these we want to identify the coefficient, the constant, and the variable. So take a moment, pause the video, and try to answer this question. The best way to learn is to get it wrong and figure out why you got it wrong. All right, so what is the coefficient? The coefficient is going to be the 4/3 pi. The pi, you say? Well, some people say. Well, yes, because it is a number. It's a number. It's not a variable. It's just a number, so it's part of the coefficient. So let's look down at the next one. The coefficient here is the 2, or the square root of 2, actually. All right, and so the next one is going to be the constant. There is no constant in the first one. The second one, that is the constant. And the variable is going to be this r right here, not the cubed, just the r. So in the next one, it's the n and the m. And to be technical, it's actually n squared square root and m cubed square root, but we won't get into that. All right, so moving on, we're going to evaluate. So pause the video and try evaluating this. I only have one example of each of these different kinds of things, so it would be great if you could pause and try it. All right, so have you noticed that I am putting parentheses where I'm going to put the number? If you don't, you will cause yourself much grief. So especially when you're working with negatives like this. So you want to use parentheses when you're plugging numbers in for x, or when you're putting variables in, or when you're putting expressions in. Sometimes we put whole expressions in for x, and we'll see that later in the course. So make sure you use parentheses. All right, and then work out what's in the parentheses before you multiply. So order of operations says that we have 3 times negative 2 squared is 4, minus 5 times negative 2 is negative 10, plus 4. So we've got 12 plus 10 plus 4. All right, so 12 plus 10 plus 4 is 26. All right, did you get 26? Great. If not, try to figure out what you did wrong and try not to make that same mistake again. Generally, the mistake happens going from here to here. All right, so example 4, evaluate for x equals 3. So try this one on your own. All right, so we've got 4/3 pi. So now when I have 4/3 pi, it really means 4 pi over 3. So you could also write it like that if you wanted to. Okay, and that's going to be times 3 cubed. All right, there's many ways to think about this. So I can rearrange this and put the numbers side by side. 3 cubed is 27. Okay, so this is what I put in right here. And so I get 27 times 4 pi over 3. Okay, so remember this is just over 1. So you can bring the 3 squared, which is, remember this is this right here, equals 27. All right, so now we want to simplify. So 27 divided by 3 is 9 and 1. So now this becomes 9 times 4, which is 36, and there's still a pi there. So you should get 36 pi. Okay, that was my last example. Thank you for watching.